Hello, hello guys. Today is the 15th of January. Lead code POTD of the 2429 problem minimize XOR. Okay, and this problem we have given a two numbers num1 and num2, and we have to find a x such that x or num1 is minimal. Okay, we have to find a x such that x XOR num1 is minimal, and we have to given that we have given that. Okay, we have given that x has the same number of set bits as num2. Okay, means the number of set bits means the number of times 1 occurring in the binary representation of a num2 is number of set bits in a num2 is equals to the number of set bits into x. Okay, so this condition has been given. We have to be remains equal. We have to be sure that the number of set bits in the x and num2 is always equal, and the x or num1 is minimal. So two conditions we have given. You can see that the question surely x and the x is the same number of set bits as num2, and the value x XOR num1 is minimal. Okay, and we have given that XOR is the bitwise XOR operation. Okay, then we have to return an integer x such that which follows this condition. Okay, and in this question it was also mentioned that test cases are generated such that it is x is uniquely determined, and the number of set bits of an integer is the number of ones in its binary representation. Okay, the definition of set bits is given here. You can read, and by the way I also told you what is the definition. And we have given num1 3, num2 5. So we have to basically we have to return a number x such that whose set bits is equals to the number of set bits of num2. Actually focus on what I am saying. The number of set bits in the x is number of set bits in num2. Okay, the count of the set bits. Okay, so set bits we have already number of set bits from the num2, and it was also saying that XOR of x and num1 is minimal, so that what is number may be. So firstly we can say that num2 is equals to 5. 5 we can represent it as a this. Okay, you can see that. Okay, 1 second. You can see that now perfectly. Okay, perfect. 0 1 0 1. So you can see that there's a number of set bits are here 2, as in 5 number of set bits 2, and we have to minimize x and num1. Minimize XOR of x and num1. We have num1 3, which can be written as a 0 0 1 1. If now we can think that how can we minimize the XOR of num1 and x has the same number of set bits, same number of count of set bits, which has in the same which is count bits of num2. Okay, so you can see that the integer 3 has the same number of set bits, and the num2, and the value of 3 XOR 3 is equal to 0 is minimal. And you can see this in this test case also. Here num1 is 1 given and num2 is 12, and we can see that representation of 0 0 1 this and 1 1 0 that, and respectively the integer 3 has the same number of set bits as the num2, and the value of value 3 XOR 1 2 is equals to minimal. Okay, now let us come to the solution of that. How can we approach the question, and what the intuition for the problem we can build actually. So first test case is about this, that let's just suppose 1 minute. Yeah, we have given num1, okay, and num3. We have given num1 and num3, sorry num2, my means say num1 is equals to 3, num2 is equals to 5. Okay, actually it is clear or not? Yeah, now it's clear. You can write num1 as a 3 0 1 1 and num2 as a 5 as 1 0 1. Now you have to be find x such that whose XOR with num1 is minimal, and the number of set bits in XOR is number of the set bits in the num2. So firstly we are checking that number of set bits is equal to 2 1 0 1. So this is the set bit in a this is the set bit, so 2 set bits in a num2. Okay, now there is no mean to for this, so we can remove this from our mindset. Num2 remove. Okay, remove num2. Now we have num1 and x and then the set bits. We have num1 is 0 0 1 0 1 1. Okay, now we have to see that how can we make XOR of x and num1 minimal. So if we try to minimize the this expression, we have to check that the set bits in a num1 is also, we have to check the set weights and try to make the weights same as in x, for the occurring the number of set weights. So we can check, we can occur the as a same as a XOR with same. So XOR with the if we make XOR of same numbers, then it will return 0. So here minimal equation we found, so it is 0. Okay, so here we can say that x is to be 3 for minimal. Okay, now again come to the test case. Num1 is equals to 1 and num2 is equals to 12. 0 0 1 it's binary representation, and 1 1 0 0 it's binary representation. Okay, it's 12 12 binary representation. Okay, and number of set bits 2. So we have to be ensure that the number of set bits in x is 2, and the its XOR with num1 is also minimal. Okay, so we have this. Okay, num1 and number of set bits in x is equals to 0 2. So we actually make x is this, then it make the minima 0 0 1 0. Okay, so you can see that it is 0 0 1 1, same digit 0 0 1, difference has 1, and same digit 0. Okay, so you will find 3. So this test case answer is equals to 3. So now you can see that the test cases, that how we can build intuition through this test cases. Okay, now let's just come to the solution of the problem. Okay, firstly we have a set bits 2. This is the variable, we have this is the main function, and in this we are calculating the set bits, number of set bits. Okay, of a set bits in a 2. Okay, my mean to say, in the num2 set bits is set bits calculated as a function which you are calculating. Okay, we can see that here the set bits is 0, and we are traversing up to the num exist, and if num is and 1 is equals to 1, it means there is a 1 weight, it increase the count and it's right shift the num. Okay, and finally we returning set bits, and initially we are initialize the result as a 0. Then after it, if a problem we have the required, if we have required set bits are more than the if we have required set bits are more, if we have more required set bits than the current set bits, okay, then we apply this portion, otherwise this. Okay, so we can check that we traverse a loop from 31 to 0 and up to when set bits up to greater than 0 and I minus minus, and if num1 and the last num1, and we are checking from the, like we are checking from here, just like we have this. Okay, just like we have a this. Okay, you know, so we are traversing of from here, we are traversing from here, my mean to say v1 left shift I. So we are actually, you know the what I'm trying to say. Okay, num1 and make ends with this. If it is true, if it is coming 1, then we set result is equal to result or one left shift I and decrease the count of the set bits 2, and we do up to this until 0 comes. Okay, and set bits 2 greater than 0. My mean to say, until the set bits required set bits occurring, we run this loop. Okay, and we have also computed result here. Okay, and if the occurrence of required widgets is less than the number of set bits in the num1, then this code will be executed. It will start from 0 to 31 and up to set bits my mean to say set bits is greater than 0. If it is 0, this is starting from the back. It is was saying it is starting from the back. If it is 0, what is saying, if it is 0, we have 2 points like this. If this is 0, we can actuate it, we can turn it into 1. Okay, and we set in the result. Okay, so we set it into the result. If it is 0, result is equals to result 1 left shift of I. Okay, actually you can got it what I'm trying to say, and decrease the number of set bits until, so this loop runs until the 31th I 31 and until the set bits 2 is greater than 0. After it false the condition, it breaks from the loops, and after this result comes. Okay, it return the result. Okay, now let's just run this code. Yeah, you can see that all the test cases accepted. Now just submit this code. Okay, you can see that it is the 100% submission, and you can analyze the complexity also, the beats 100%, and you can see that is O of 1. We have solved this problem in O of 1 because now you can see that we are actually calculating in set weight calculator on this. Firstly, it mean to say we are not traversing, we are actually goes up to maximum 31th weight, because here we have given 2 to the power 2 to the 10 to the power 9 as a constant, so we can relate that to the 2 to the power 31. So we can actually run this loop up to 31, which is actually doing itself in the backend. Okay, then actually it is also a constant of 31, and now we can say that it is a loop of 31 maximum, it is loop of 31, so overall it is O of 1. The most optimized approach we can solve it. Okay, now you can see that all the solution. If you want the solution, just DM me, direct comment, and I will send you the source code in your comments in your. Okay, if you just like the video and you like the question also, and if you are daily solving this problem of a LeetCode POTD, or if you are watching this video until now, so you can comment, and you can like this video, you may like the video, and just thank you for watching the video. Okay, thanks.